Hi, after today's lesson, a few of you guys had asked me if I could go through the answers, so I decided to just make a quick video to explain this. So this is the 1D accelerated motion coding activity, and you should have gone in and looked at this code. That's what we were doing today. And this is the code of a car, I guess we're calling this box, that's moving to the right at constant velocity, right? And it's plotting both the position and the velocity over time. And I'm asking you to basically manipulate the code, right? So going back to the worksheet here, I'd like you to copy this code, all right, and put it in your own glow script, which I have over here. So I'm going to edit that program. And we have a number of tasks that you're asked to do. Okay, so the first task that you were asked to do, whoops, not that one, oops, this sheet over here, was to change the position of the car. It starts at the origin, as you can see in the picture here. We want it so that it starts at 50 meters instead. So let's go over to the code here. You'll see that in this spot where I define the car, it is initially starting at the origin. So all I have to do is just change that to a 50, and so that if I run the code, I can see now the car is starting at 50. Okay, next question is, you'll notice that there's a trail of dots behind the car that moves along the ground. All right, how did I enable that feature? All right, and how can I change it so that they're either closer together or further apart? So going back to the code over here, you can see there's dots right in there. If I zoom in, maybe you can see the dots right over there. All right, how can I make them closer or further apart from each other? Okay, so one way to do that is simply making the car, say, changing the speed of it. Let's say we make it go at 40 meters per second, and if I run that, you're going to see now the car is going a lot faster and the dots are getting further apart from each other. But they're still equally spaced because it's moving at constant velocity. Okay, or if you want it close together, you could just make it go, say, at 10 meters per second, this velocity, and you can see the car is moving much more slowly, and then these dots are really, really close together. Alternatively, one thing you could do, let's say we went back to 20, you could change the interval at which these points are laid down. So this little feature in here, this attribute allows points to be left behind. So make trail equals true is allowing the feature of adding dots as the object is moving. This indicates that I want points instead of, say, a line that's connecting the points. And then now it basically does it for every 50th one, because this increment of time is really quite short in time. And so if you do an interval of 1, for example, or just no interval at all, then you're going to basically see that it'll be just a line, because the dots are so closely together it looks like a line. Okay, so if you want to change the spacing as well, you can just change the interval at which the dots occur. Okay, going on to the next question here. I've asked you to change it so that the program is going to indicate the car's final position. Okay, so I'm just going to cut and paste that in here in the code. So now you'll notice at the end of the program I have a print statement. And if I just type in, say, oh, the car's position is, say, 200, then when I run it, let me just shorten the time increment to be a little less so it goes faster. If I run the program now, you're going to see that it is now just typing in 200. But maybe it's not 200, it looks like it's actually 250. So you really actually want to know what the actual value is, right? So a better way to do it is to call up the variable that is going to be indicating the car's position. So I can say the car's final position is, all right, then I can put comma, and then car.pos.x, comma again, because maybe we want to indicate units as well. Okay, and now when I run the program, you're going to see that at the end there's a dialog box that gives you the car's position. So what happens is this is printing the text, and then this is calling up the value of the car's position after the end of the loop. Okay, moving on from there, the next part was we see that the car is moving to the right. What does the t plus t equals dt line mean? And what would happen if you changed it to, say, 0.02 seconds, for example? So if you change that increment right now, you notice I already was playing with that and put 0.1. This changes how often these dots are occurring, right? So each time it runs through this block of code, we need to progress to the next step. And in order to do that, we have to increment time. So this step right in here, I'm going to add a little comment, it increments time. So basically it's taking the time that it had in the last round and adding an increment of dt. So let's say the very first time it goes through, the time is set to be 0. So it goes through here and calculates the position. And then when it gets to this line, it's going to add 0.02 to it. So now the new time is not 0, but it's 0.02. So then it goes back to the top loop. Are you less than 10? Yes. It goes through here, here, and here. And then when it gets here, now add another 0.02. So now it's going to be 0.04. And then it's going to go back to the top of the loop and then do it again. And then it's going to keep on incrementing, say 0.04, 0.06, 0.08, 0.1, etc. until you get to a point where you are no longer less than 10. And that's when you exit out of the loop and print this statement. Okay, so that increments time, essentially, this step. So now we see that the car is moving at constant velocity, but we want to make the car accelerate to the right at 4 meters per second squared. So we're going to be using this kinematics equation right in here, okay, to do that. So in order to do that, we are going to modify this line 27, right? So we are going to add in 0.5 times a times t. And I see a lot of people doing this, all right? And of course, you need to indicate what a is. So I'll put over here another line that a equals 4. If you run the code like this, not going to be right. It looks really weird, isn't it? It's not doing it correctly because it's not interpreting this properly. This is not t squared. In Python, to do something raised to the power of 2, you have to use star star then 2. That's raising it. That's like raising it to a power of 2. If you put a 3 here, it would be raising it to the power of 3. So this is actually t squared. Or alternatively, you could just write t times t. Okay, if you're not sure, just do t times t. So star star. Now, hopefully when we run the program, you should see it now curving like a parabola. Okay, and you can see the dots are getting further apart as well. All right, moving on to the next step here. I've asked you to update the velocity time graph because when you run play on this, you'll see that the velocity time graph is not changing. And you can clearly see that the object is getting faster and faster and faster. That's because we haven't updated the velocity. So in order to do that, you're going to need to update the velocity. Right now it's set at 20. Well, it's not 20. It gets bigger and bigger and bigger. So hopefully you can remember the kinematics equation for that. I'm going to add in a line and say v is equal to v initial plus a times t. So now it's going to calculate the velocity. I've seen a few people actually take this little bit of line in here and insert it in here instead, and that works too. So if I run this now I should hopefully see that the velocity is increasing linearly. Okay. I do notice that the velocity, oh yeah, it perfectly fits in there. That's no problem. Okay. Let's go on to the next step then. In number 7, we would like to create another object called a truck that's on the right side, starting at 400 meters, and it has a constant velocity of 20 to the left. So let's create that object and then also animate it so the truck's moving correctly. So in order to do that, I'm just going to try to make life a little bit easier and just copy this paste that I call car. Okay, and I'm going to rename it truck. So I'm making a new object. It's not going to start at 50. It's going to start at 400. Okay, let's keep the size the same, but let's call it a color that is red. Okay, and then of course we need to also define some initial conditions. So for example, you might have x01, I guess, is the truck.pause.x. The truck has also, I'll call it v1, and it's going -20 to the left. We're not going to bother with acceleration because it's not accelerating. So we've defined the truck. We've set out its velocity initially is -20, and its starting position is set at 400. And then in this code over here, we're going to now make the truck move. So I'm going to add another line, truck.pause.x equals, now make sure I'm not using x0, that would be for the car. I need to use x01. So x01 plus v1, right? That's what the velocity is, v1 times t at the same time. And now hopefully I have a truck that is moving from the right side and going towards the car. Okay, be notice that it's not plotting the truck's movement because I have to also do something, and that's going to be my next step. So moving on from here, we need to update it so that both graphs show not only the car, but also the truck's motion. So this is a little bit trickier. And by the way, when I get kind of stuck on things and I don't know how to do things here, if I learn something, I might go and just under Google, just type in glow script and then graph, for example, and then you'll be brought to some kind of help page, and you can kind of read about it through here and tell you all sorts of things about graphs. Okay, some of the more advanced features as well. Okay, so going back here, to make, right now when I run it, I'm only seeing in the graph the car in blue. We want to actually make the truck move as well. So really there are actually going to be two curves or two lines on the position graph and two lines on the velocity time graph. So what will we do here? We don't need to recreate a new graph. We already have the two graphs. What we need to do is we need to create two more functions. Okay, maybe I'll just copy and paste these two functions, but I'm going to call it function 3, F3, function 4. All right, and instead of using blue, I'm going to be red and red. So function 3, which is plotted on graph 1, which is our position versus time, is going to be for truck. So I have to now write another line in here. It doesn't matter where you put it. I guess I'll put it right after this line. We're going to put f3.plot t, truck.pause.x. I also need to plot the velocity of the truck. So f4.plot t, but the velocity of the truck is v1. Okay, and I think that is it. So here I just define the functions that I'll be plotting, and then here I'm plotting the actual points. So if I run it now, I can see both. You can see that the truck is going here at -20, and there's the other one. There's the car. Maybe I could change the scale on it, so maybe I can see it, like maybe I can change this to like make it 30. Maybe it looks a little bit more clearly. Okay. So now, the last task, I believe, is I want them to stop when these two things meet. Okay, so we're going to edit our program here once more. Let's go to the next task. We want to figure out how to stop the program once the car and trucks are colliding. Okay, so I saw a few people, when they were doing this, were trying to put if statements in here, and then they use like when they're equal to each other, but you have to be careful when you set them equal in terms of position, because you might just increment amount of time right over that point where they're equal. So I wouldn't use a point where like when they're equal, let's stop out of the loop and break out of the loop. Personally, I would just rather change the condition with the loop. I'm right now just running for 10 seconds. I don't need to run for 10 seconds. I just want to run until they stop. So I can say something like, while car's position on the x is less than the truck's position along the x-axis. And I can just make that one change. And so now they're going to continue moving until these two objects basically are no longer past each other. But now there is one little catch I should point out that right now they're overlapping with each other. That's because we're looking at the point when the center and centers are on top of each other. So you need to add in a little piece in here, like I need to add in the fact that there is a, maybe I have to do minus, I think, let's start minus truck dot size dot x. And also we have plus car dot size dot x and divide that by 2, because really we're looking at the center to center of them. And we don't want them to overlap. We want it so they stop right at their two sides. I don't know if it's plus or minus. Maybe I've got that one wrong. Let's see. I always make that mistake. So, nope, that's perfect. And there we go. Now they're just stopping when they just touch each other. Okay. So, last but not least, we need to update it so we tell the position, the velocity, and maybe the acceleration of the car and the truck. So we just add in some printed statements in here. So we can say the car's final position is, we've got that, and is moving at a velocity of, let's put in car dot, oh actually I think it's just v, right? Comma, and then meters per second. Okay. Oh, and then maybe I can add in like at a time of t, comma, seconds, the car's velocity is da da da. By the way, it's getting, maybe I'll just move this over to the next line. As long as I indent it, it should be fine. Let's just see if that runs here. Okay. Oh, it doesn't like that. Why? Because it is, maybe I should just put it all in the same line. All right, I shouldn't indent it like that. Let's just do it like this and see if that works properly. So if I run it now, hopefully I'll be getting the car's position and the velocity and the time all indicated here. Oh, I did not have t in there, and I have some errors with quotes in here. Let's see what I did. At time t, oh, I have single quotes and double quotes. I should not be doing that. Maybe I'll just do a single quote kind of thing. That might have caused the problem I had earlier. Okay, and of course I have also, maybe I'll add in another statement here. Print the truck's position is, and then truck.pos.x, comma, and then meters. Okay, hopefully I didn't make any syntax issues. Oh, it doesn't like this quotes in here. Maybe I should just use double quotes in here so that it doesn't mix up single quotes in there. That might make a difference. And same thing here. I think that's okay. Okay, there we go. It's working. We'll see if it works at the end. If I don't have any problems with typing all the information in. Yeah. Okay. I will note that this time is off. It should be actually 0.0, like it has a little bit ahead of that time. So really, that time is slightly off because at the end of the loop, I add another dt to it. So technically, I should be subtracting 0.02 because at the end of the loop, there's a little bit of extra time in here, and that's more appropriate in there. Okay, so is there anything else that I need to do? The last question is, what kind of motion is being modeled by the truck and the car? Hopefully you can see that the truck, which is in red, is moving at constant velocity, and the car is an accelerated motion. Okay, and that is it for my extra help on the task we were doing today. Bye-bye.